So in the last session, we learned about four important operators, which that operators we are going to use it for interpolation purpose. So let me first just recall the definitions that we seen in the last session for the operators here. The first one is a forward difference operator. Yes, anyone can tell me what is the definition of forward operator? Or let I write it here. Delta fx. Can you tell me what is the delta fx? Quick.
fx plus h minus fx.
Correct. F of x plus h minus fx is a forward difference of fx here. Correct. Next we have is a backward difference. Yes, anyone now? I want a backward difference now. So del of fx.
fx minus fx minus h.
Good. Fx minus f of x minus h. That's the formula, or that is a definition of backward difference for the function fx. We have then central difference. So central difference is denoted by a small delta. So this is a small delta of fx. Now this is a little tricky here. So generally this delta is not we define it for fx. We defined it for yes, anyone knows it. Delta is defined at
Plus h by 2.
correct delta f of x plus h by 2, and then it is same as forward difference only, f of x plus h minus fx, because we are subtracting functional value of x plus h with and that fx at x. So that difference exists, the difference of that function exists at the center of that interval. The interval is x to x plus h. X to x plus h, in that interval it is x plus h by 2 there. That is a central difference. And the last is actually the first is important, forward, then the backward, and the last, that shift operator, is also important. Yes, it is very simple definition. What is the e of fx? What is the e of fx? Quick. No one. E of
x
fx,
plus nh.
x plus h only, because just e is there. If we have e square of fx, we say it is a f of x plus 2h. And if we have e raised to minus 3, say e raised to minus 3 of fx, obviously we have to shift that x to minus 3h point. So f of x minus 3h. Is it clear? F of x minus 3h is there. Got it? Okay. So that about the operators, mainly forward operator, backward operator, and shift operator. They are the most important operators that you should remember. So come to the today's agenda. So in today's session, from this topic, finite differences, you are going to learn. You are going to learn about the relation between the operators. So you should able to derive the relation between the given operator. So the best part of this type of question is you are given that relation. So you have the answer with you. Just you have to prove that LHS is equal to RHS. Okay, that about they prove the relation between the operator. That is the first point, and then you have to find out the missing values from the table. Okay, that are the two things that you will learn today here. So come to the question. The first point here, prove that delta is E minus 1. This is a one line proof, and generally this type of question can come for 2 marks there, or it is for multiple choice question, MCQs there. So our aim is to prove delta is E minus 1. So just we start with a definition. By definition, the proof will be like this, or proof or solution of this equation. I will say the proof. By definition of a delta of fx is f of x plus h minus fx. This is just by definition. Can you tell me how this f of x plus h can be written in terms of a shift operator? Yes, what is the value of f of x plus h in terms of e? Is it
EFX.
Correct, good. So this is the important thing that you should get. EFX minus fx, that as it is. Now we can take this function fx outside and we can keep operator separate. So this e minus 1 will be as it is and that fx will come outside. Now you'll observe delta of fx is the same as e minus 1 of fx. From thus we proved here delta of fx is always the same as e minus 1 of fx. So this is for any fx. Now we are not proved it for some particular fx. It is for any fx. General fx is there. So this gives us that delta, the operator delta should equal to the operator e minus 1, and that is the end of the proof. So see, the proof is very trivial. It is just start with the definition and come to the required part.
Excuse me, sir.
Yes.
Could you repeat from the second part, like delta fx equals e minus 1?
This is a
We got
this is a
disconnected.
by definition of a shift operator. E of fx is f of x plus h, na? E of fx is f of x plus h. That shift operator definition
Yes,
is used only. Why it is used? Because we have to prove that relation. Got it?
yes, sir.
Any other doubt? Anyone? So that about the proof of the first property. These questions generally can come for the multiple choice part or it is for 2 mark question. Already we discussed this. Okay. So anyone want to write it or should I move to the second?
So you can move ahead.
Okay, good. So next here we have to prove now del equal to 1 minus 1 upon e. Our aim is to prove del equal to 1 minus 1 by e. So sometimes the proof will come for this one or sometimes prove del equal to e minus 1 upon e. So both are same. Okay. So consider again the proof of the second. For the proof of the second, we'll consider the definition of del operator. Now what is a del fx? Yes,
Fx minus Fx minus h.
correct. Now can we write f of x minus h in a shift operator? Is it possible to write this in shift operator?
E raised power minus
Yes,
f.
e raised to minus 1 of fx. This is by definition of a shift operator. E raised to minus 1 of fx is f of x minus h. And now exactly same thing we'll do it. We'll take fx as a common. So 1 minus e raised to minus 1 of fx. Now again this holds for any fx. Okay, this holds that del fx is the same as 1 minus e raised to minus 1 of fx. Thus del operator, this del operator is nothing but it is 1 minus e raised to minus 1. That is the end of the proof. But exactly same thing can be written as del equal to 1 minus 1 upon e, because e raised to minus 1 is nothing but it is 1 upon e, that way. Or if you do a cross multiplication, you'll observe you'll get e minus 1 upon e. So whatever the relation you want to prove, that you can prove it here. That's all. So I will tell you this second proof, whatever we proved right now, this second one, this is asked 2 to 3 times in old question paper for 2 marks there. The question is generally to prove that. So this is the proof that hardly you would write definitions only, definition of del operator, definition of shift operator that you have to use, and then you can say hence del is 1 minus 1 upon e.
Sir, can you please show me the shift operator slide? I joined a bit late.
You can go through the recorded video.
Okay, sir.
Okay. Any other doubt, anyone here?
No, sir.
No, good. Now here are some we can say the examples. Now these are not relation between the operator. Now we have to prove that delta of sine x is this one. Okay, so we'll go one by one. Let me focus first only on the first part here, which is a delta sine x. So just we have to use a definition, nothing so great, and some trigonometric identities we require to simplify it. So by definition, so if we start the first one, delta of sin x. By definition of delta operator, can you tell me what is the delta of sin x? Quick. This is a forward operator.
Yes, sin x.
Sin of x plus h minus sin x, is it? Already we've seen that is the delta of
Yes,
fx
sir.
is f of x plus h minus fx. Now this is the answer. Actually, we got the answer, but the question is not this one only. Where the question is show that. So we have to come to this part. So what should be the next step? Anyone? How to go?
Formula of sin a minus sin b.
Correct. So this is a, we can say, defactorization. It is not. It is factorization formula. Sorry. So that is known as factor. Sin c minus sin d or sin a minus sin b. Sin a minus sin b is a 2 times cos. Is it cos a plus b upon 2 into sin a minus b upon 2, something like that? Okay, check. So this is a sin
Yes, sir.
a minus sin b is 2 times cos of a plus b upon 2. This is a and this is a b. So a plus b upon 2, that is x plus h plus x upon 2, a plus b upon 2 into sin of a minus b upon 2, that is x plus h minus x upon 2. And next step is the required answer, which is a 2 times cos 2x upon 2 is just x plus h by 2 into sine h by 2. Remember, the best part of these questions is always the answer is with you. You have the left hand side, you have the right hand side, the answer is there. Just you have to manage the middle steps. Okay, so start with the definition of the operator, use some identities or formulas and get the required answer. So simple, is it? So this is again 2 mark question. Are you completed?
Yes, sir.
Yes, sir.
Okay. So the next one then. So second is a delta of tan inverse x. Delta of tan inverse x. So by definition of a delta operator, we'll take it is a tan inverse of x plus h minus tan inverse x. Now again, it is some identity is there like tan inverse a minus tan inverse b. What is the formula?
Yes, sir.
Tan inverse.
X plus 5y minus 1 minus x minus xy.
Okay, so this is a tan inverse of a minus tan inverse b is tan inverse of a minus b upon 1 plus ab. So this is x plus h minus x. This is a minus b upon 1 plus a 1 plus ab. So it is x plus h into x. I think is that is a formula. You can check. And this is just a simplification gives us the required answer then. So that about xx gets cancelled. Numerator left only h. And if you simplify this, this is 1 as it is. X square is there. Plus hx is there. And plus 1 is there. And that's the required answer. So the identity that we used, tan inverse A minus tan inverse B, is tan inverse of A minus B upon 1 plus AB. Done?
Sir,
Yes.
as the tan inverse is a odd function, so I can send the minus inside and write tan inverse minus x, and their plus can also be possible,
Okay,
no?
yes, it's possible, but at the end you will get the same result because there is a formula for
Yes, sir,
tan
but
inverse.
it's easy to remember the formula,
Okay,
so I
okay,
was.
no issue. Your choice. So are you completed this?
Yes, sir.
Okay. Last one then, third. This is a, also I can give it for self-study, but let me do it quickly. Delta log x. Yes, tell me the quicker steps here. Log of. Next step, yes.
log A by B.
Correct. It is
Like
a
log x
x
plus x by
plus.
x.
Correct. Log a minus log b is log of a upon b, and that's the required answer. Okay. So that about our questions where either you have to prove some relation between the operator, or you have to examples where you have to just use the definition and you can prove the required results there. So these are very simple examples. They are multiple choice based or 2 marks question only. Okay. Now come to the second point. Second point of the today's agenda, that we are going to find the missing terms of the function using finite differences. Okay. So the second point, the example for the second point is here. We are given the values of x and y. We are given the values of x and y here, and the question is find the value, find the missing value. The missing value is here. You'll observe the missing value is at x equal to 3. What is it? Y. So this is missing actually. The missing value is y there. So that we have to find out. And now there is one more extra part in the question, that is why this obtained value is a different from 3 raised to x. Why 3 raised to x is only used because actually whatever the values of y, actual fx is 3 raised to x. You will observe 3 raised to 0 is 1, 3 raised to 1 is 3, 3 raised to 2 is 9. So 3 raised to 3 raised to 3 is a 27. It should be a 27, and 3 raised to 4 is 81. So actually the missing value should be a 27 because these values are written with the function 3 raised to x, but we are not going to get that answer. Our answer will be a different. Why we'll get the different answer? Yes, anyone? Any idea? Why the answer we are obtaining by finite differences are different from, sometimes it is different from the actual function. Yes, we discussed that actually in the last session. Someone is on the chat. Just check it. Unable to unmute. I'm not. Others are able to unmute. I don't know. Check. Yes, you can unmute there. You can unmute yourself. I can see. Yes, anyone else?
Sir, x value is equidistant.
No, my question is, when we compute these approximate values by using the finite differences, uh, that missing values may differ from the actual value. What is the reason? The reason is we discussed actually in the last session, and that reason is uh, we are calculating the values by approximating with n minus 1 degree polynomial. So we are not going to take that fx as 3 raised to x. 3 raised to x may be the actual function. But instead, what we are going to do it, we are going to, how many pairs of x and y we are given? The first pair, 1, just 1 minute, is 1 pair, second pair, third pair, and 4 pair. So whenever we are given 4 pairs, we will approximate this function by a cubic polynomial. So we are going to get a cubic polynomial, and with the help of that cubic polynomial, we are going to predict the value of y for that value of x. Okay, so right now it is a differ because with that actual function is 3 raised to x, that is a differ from cubic polynomial. So we get approximate values at the end. So this is always happening. So let me start here how to get that missing values. The missing values we can get it by the table also, forward difference table. First we have to denote the missing values by this we can say alphabets. So we denote the missing values by ABCs there, okay, like this. So to get this first we have to prepare the table. The first values of x is written, values of y is written, and the missing value is written by a. The missing value is written by a here. Okay. Now we calculate the forward differences. Remember the forward difference table I written little different way. Previously I am writing in alternate rows. So this way also you can prepare the difference table if you want to save your space in the notebook. So just 3 minus 1 is 2 written, 9 minus 3 is 6, a minus 9, 81 minus a. So these are the first order differences. Any doubt in column of delta y, how delta y is written? Is that clear? Is that clear? Delta y is written there. Is there any doubt? Quick.
No, sir.
No. Okay. So similarly, delta square y, delta cube y, delta 4y, all their higher order derivatives calculated. Higher order difference is calculated. My mistake. 6 minus 4, 6 minus 2 is a 4. A minus 9 minus 6 is a minus 15, and so on. Lastly, this minus 3a plus 105 minus a plus 19. Okay, becomes this one. Okay, this is the value we got it by next value minus same value, that way. So this is the fourth order difference. Now at the beginning only we said what is a polynomial? What is a polynomial that is used to approximate these values? Yes, which polynomial we are assuming that we are approximating the data? What is the degree of that polynomial? What is the
X.
what is the degree of a polynomial that approximates these values of x and y? I'm asking degree. How many pairs were given? 1, 2, 3, 4.
Three.
When 4 pairs are given, the degree of a polynomial is 3, because the degree of polynomial is always n minus 1 when we are given n pairs of x and y. So actually we are approximating the data by a polynomial of a degree 3. So what should be the fourth difference? If a polynomial is of a degree 3, then the fourth difference should
Constant.
no, fourth difference should be 0. Yes, if degree is 3, then third difference is constant. So the third difference should be constant. So we can do one thing. Either we can equate these two. Either equate a minus 19 equal to minus 3a equal to 105. And because it is a polynomial of degree 3, it is polynomial of degree 3, so the third difference should be a constant. So as third difference is constant, a minus 19 should equal to minus 3a equal to 105 and solve it, or take fourth difference as a 0. Take a fourth difference as a 0. So we are going to take here fourth difference minus 4a plus 124 as a 0, and you will observe the value is coming a equal to 31. A equal to 31 is the answer. Any doubt? And the answer for the second part of the question is also written there. You will observe that answer is, as fx is a polynomial of degree 3 and which is different from 3 raised to x, so we get a different value. See, what is the value of a missing value? We get 31, but actual value is a 27. Okay, actual value is 27. Always it is near to that. Right now we are just approximated by polynomial of degree 3. Because of that, it is more away from 27, that actual value. But suppose instead of giving the 4 pairs, suppose we are given the 10 pairs, 10 pairs of x and y. Remember, the accuracy goes more accurate, so it goes closer to the 3 raised to x. Means we may reach to the 27 also. Got it?
Yes, sir.
Okay. So this is a way we generally find the missing values from the table. So let me do one or two examples on this, and then we'll stop it. Okay. So this is one question here. Next. So here we are given u1 as a 8, u3 as a 64, u5 as a 216, and find u2 and u4. So how many missing values are there? How many missing? Two missing values. How many pairs were given? How many pairs were given?
Three.
3. Okay, even though some of you may think that x values are not given, but u1 means x equal to 1, u is 8. X is 1, u is 8, x is 3, u is 64, x is 5, u is 216. So 3 pairs are given. So we are going to approximate this data by which degree polynomial? What is the degree of polynomial that we'll use to approximate the data?
2.
Yes, 2 is the correct answer. The degree of a polynomial is a 2. So as it is a polynomial of degree 2, so second difference should be 0 or constant? When the polynomial is of degree 2, the second difference should be constant, correct, and third difference should be 0. So we'll come to that. So here is the table first. Values of x and u is written, x1 to x5. Out of that, x2 and x4, x2 and sorry, u2 and u4 are assumed as a constant, a and b. Got it? Here is a and b. This is a and this is b, which are missing values. Then just forward differences are calculated, and we came to here up to third differences. Now, as three pairs are given, 1, 2, 3. Third differences are equated to the 0. Third differences are equated to the 0. Got it? So whenever three pairs are given, the third difference should be 0, second difference should be a constant. So this should be equal. All these three should be equal, or this should be a 0. Got it? So when we solve these two equations simultaneously now, so if we say this is the first third difference should be 0, second third difference should be 0. Solving these two equations simultaneously, okay, solve it for a and b, and you get the required values of a and b. This way we get a missing values. If you have the doubt, you should ask. Okay, you can ask here. Any doubt?
No, sir.
No, sir.
Okay. Okay, so this example is for homework. Try it your own. It is just for your practice. Answer is also given. There is one missing value. Just I want quick answers of few questions. How many pairs were given?
So what is the question?
How many pairs of xy were given?
4,
4. What is the degree of polynomial will approximate?
3,
3,
Which difference will be the 0?
4.
Fourth difference will be 0. Correct. That's the way you can continue, and you will get the value of a there. Okay. So that's for today.